Welcome back to Algebra 2, still in our unit of quadratic functions. Today we are going to continue on talking about complex numbers. This is part 2. So first off, we want to find x and y. If we have 3x minus 5 plus the quantity y minus 3 times I is equal to 7 plus 6i. Notice on the right-hand side of the equation we have a 6i, that's 6 being multiplied by I. On the left-hand side of the equation, we have a y minus 3 times I. Since those are both being multiplied by I, it would mean that our y minus 3 would have to equal 6. So we would solve that, add 3 to both sides, so that means our y should equal 9. Then we look at what we have left on the equation. We have a 7 and a 3x minus 5, which would mean that our 3x minus 5 would have to equal our 7. Solving that equation, we'd add 5 to each side, so 3x is equal to 12. And then we divide both sides by 3, so x here would equal 4. So this would mean our x would be 4 and our y would be 9. So our solution for this one would be 4, 9. The next problem we want to simplify. Notice right here we have a complex number in the denominator. For us to be simplified, there should be no complex numbers in the denominator. So when we say no complex numbers, that's no i's. So in order for us to take care of this, we just have to recall our chart. I equals I squared equals negative 1, I to the third is equal to negative I, and I to the fourth is equal to 1. So if we can change the I into an I squared, then we would be able to get rid of that I in the denominator. Well, if this is 5i, I just need to multiply it by another I, and it would become I squared. Well, if I multiply the denominator of the fraction by I also have to multiply the numerator of the fraction by I. So our numerator, we distribute the I throughout, so we would have 4i plus I squared. And in our denominator, we would have 5i squared. Now we know I squared is negative 1, so we're going to replace our I squareds with negative 1. This would leave us with 4i minus 1 over 5 times negative 1. And 5 times negative 1 we know is just negative 5. Now there's one other thing, is we typically do not leave negative signs in the denominator. So if we multiply top and bottom by negative 1, that would take care of it. So we'd then have negative 4i plus 1 over positive 5. And just rewriting this so that the minus sign is in between those two, 1 minus 4i over 5 would be our simplified answer. Let's do another example. This time we have the quantity 1 plus 2i times the quantity 5 minus 3i. So to do this, we would just FOIL or double distribute. So 1 times 5 is 5. 1 times negative 3i is minus 3i. 2i times 5 is plus 10i. And 2i times negative 3i is minus 6i squared. We can combine our like terms. So 5, negative 3i plus 10i would be plus 7i. And I squared we know is negative 1, so this is like negative 6 times negative 1, which is a positive 6. Then we can combine our 5 and 6 together, leaving us with 11 plus 7i. We're going to do the same exact thing for our second example here. We can FOIL or double distribute. So we have 2 minus I times 2 plus I. So 2 times 2 is 4. 2 times I is plus 2i. Negative I times 2 is minus 2i. And negative I times I is a minus I squared. Notice our 2i minus 2i cancels each other. Our minus I squared would change to a minus a negative 1. So we have 4 minus a negative 1, or just 5. Okay. And then our last simplifying, once again, we see we have an imaginary in the denominator. Now this one's a little bit different because it's 3 plus 6i. In cases like this, we're going to have to multiply by the conjugate. We have to multiply by the conjugate here because if we just multiply by I, if we just took 3 plus 6i and multiplied it by I, we would then have 3i plus 6i squared, still not getting rid of our i's. When we multiply by the conjugate, we can get rid of those imaginary numbers. If we have a plus b, its conjugate is a minus b. And it gets rid of the imaginary numbers because when we multiply them together, the outsides and insides cancel. Exactly like they did for this example. 2 minus I times 2 plus I. Notice our solution no longer has complex numbers in it. So that's what we're going to do for this one. So here, if our denominator is 3 plus 6i, we're going to multiply it by 3 minus 6i. If we multiply the denominator by that, we have to multiply the numerator. So the numerator, we just distribute our 2i. So 2i times 3 is 6i. 2i times 6i is 12i squared over 3 times 3 is 9. 3 times negative 6i is a minus 18i. 6i times 3 is a plus 18i. 6i times negative 6i is a minus 36i squared. Every time we see our I squareds, we will replace them with negative 1s. So this then is 6i minus 12 times the negative 1 would become a plus 12 over negative 18i plus 18i cancel. And then our minus 36 times the negative 1 would become a plus 36. And 9 plus 36 is 45. We can simplify this one step further because 3 is a factor of 6, 12, and 45. So we could divide top and bottom of this fraction by 3 to give us 2i plus 4 all over 15. So that would be our simplified version. And we got that by multiplying by that conjugate.